Differential calculus. If you're taking an advanced math course, then you've hopefully heard the phrase, but what exactly does it mean? Well, to differentiate is to take the derivative of a function. And what's the derivative? The derivative gives the rate of change of the original function, and the rate of change is also called the slope, or the gradient. So, how do we find this? Let's look at this function. 4x cubed minus 7x squared plus 4x minus 34. That is what we're going to call f of x. Now, to take the derivative, we use this formula. F prime of x equals nx to the power of n minus 1. Now, f prime of x is just how you say the derivative. So it's just the derivative of f of x. And another way to write that is dy over dx, but we're going to stick with f prime of x. So, with the first term in this function, we're going to apply that formula to it. Alright, so n here is the exponent, and so our exponent here is 3. So we get 3 times 4x to the power of 3 minus 1, or 12x squared. You see how that works? Let's go to the next one. Negative 7x squared. So that gives us negative 2 times 7x to the power of 2 minus 1, or negative 14x. Our next one, 4x. So here we don't see an exponent, but when you see x just by itself, you know that the exponent is going to be 1, because anything to the power of 1 is just itself. So then our n here is 1. So we have 1 times 4x to the power of 1 minus 1. Now, 1 minus 1 is 0. And what is something to the power of 0? Well, anything to the power of 0 is just 1. So then we have 1 times 4 times 1. So that is 4. Now we have our next one, negative 34. And so that's pretty much negative 34 times x to the power of 0. So if it's x to the power of 0 and we're multiplying our whole term by whatever the exponent is, then we just get 0, because 0 times anything is just 0. So this is what we get if we put all of our separate terms together. We get f prime of x equals 12x squared minus 14x plus 4. So that's our derivative. And this is what it looks like if you graph it. No, sorry, this is not the derivative. The next slide is the derivative. This slide is our original function. Kind of funky looking with terrible numbers there. I mean, all numbers are great, but these ones are just really a lot less great than other numbers. This is what it looks like when we add in our derivative. Now, you probably can't even tell which one it is, but it's this blue one here, because it is a quadratic function, which is less than our original cubic function. Now, to see what we can do with the derivative, we're going to use a different function. Here we have f of x equals x cubed minus 3x squared minus 9x minus 5. So, x cubed gives us 3x squared. Negative 3x squared gives us negative 6x. Negative 9x gives us negative 9. And negative 5 gives us 0. So our derivative is f prime of x equals 3x squared minus 6x minus 9. And if you graph it, this is what it looks like. So here we have a point marked on here, and that is 5, 0. Now, why is this important? Now, it's not really. It's just important for this purpose. We're going to find the gradient of the tangent at this point. And so to do that, we use the derivative. So we are going to input the x value here, which is 5, into our derivative. So that gives us 3 times 5 squared minus 6 times 5 minus 9, or 75 minus 30 minus 9, or 36. So that is going to be our gradient. And why is that going to be our gradient? Because that is the output of the derivative, and the output of the derivative is equal to the gradient of the tangent. So if we draw that tangent here next to our first equation, then we see it kind of covers it up. Now, why is that? That's just because it's really, really close, and they both have really steep slopes. And if you take a closer look, you'll see they actually don't touch at any other point than the one that they're supposed to. So what we did just now is we found the slope of the tangent at x equals 5. Now, another thing that we can do is find the minimum and maximum. So we can do this by setting the equation equal to 0. And this works because the output of the derivative is equal to the gradient of the tangent. And we know that at the minimum or maximum point, the tangent will be horizontal, and horizontal lines have a slope of 0, or a gradient of 0. So the gradient of the tangent is 0, and that's our output. So to solve for x, we're going to factor, and that gives us 3x minus 9 and x plus 1, which we set each to 0, and we get x equals 3 and negative 1. Now, if we graph this, we are going to see that at x equals negative 1, we have our maximum, and x equals 3, we have our minimum. Now, there's other ways to figure this out if you don't have a calculator. For example, there's the second derivative test, and you can also just input the values before and after the x value that you have, and you can see how the slope between those relates to the number you first had, but graphing is the easiest one if you have that available to you. So, we know that 3 is, well, x equals 3 is where we find the minimum of our function, and x equals negative 1 is where we find a maximum. So that is yet another one of the cool things that you can do with derivatives. Anyways, thank you very much for watching, and good luck with derivatives.